We're going to bring a bunch of things that we know together today. We know how to solve quadratics. Right? We know how to factor. If you have a quadratic, you can put it in the box, and then you can find out what the factors are, and then you can find the roots. But sometimes quadratics don't factor. Why don't they factor? When would a quadratic not factor? Any idea? You remember? When would a quadratic not factor? What sort of answers would it have? Nobody? When it does factor, what sort of answers does it have? So x could equal, if it factors, what sort of answers might there be? X could be what numbers? Not any real number, only really nice numbers. So if the quadratic factors, then we have nice numbers. For instance, x squared minus 8x plus 7. We put x squared in the box and 7. We multiply those together, and I get 7x squared. Are there factors of 7 that add to be negative 8? Negative 7 and negative 1. What's my next step? Look at the top row, and I pull out an x. And if I pull out an x, what's left? X minus 7. And then if I take an x out of the first column, I get x minus 1. So my factors are x minus 7 and x minus 1. And I get x equals 7 and 1. So if a quadratic factors, the answers are nice numbers. They're either whole numbers or they could be fractions. If there's a number in front of the x squared, it's possible for the quadratic to have fraction answers. But what about those quadratics that don't hit at a nice number? Well, we created the quadratic formula for that. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And the nice thing about this formula is it always works. It works when the answers are nice. It works when the answers are irrational, which means they have some square root in them. It works all of the time. If I had x squared plus 2x minus 9, is that going to factor? Are there factors of 9 that add to be 2? My only options are 1 and 3 and 9, and they don't work. Okay. So I need to use the quadratic formula. In this case, a equals, the number in front of the x squared, which is 1. B is equal to 2, and C is equal to negative 9. Okay. I put them in the formula. Negative B is negative 2 plus or minus, and I recommend that you just square it. Square B and then put it in here. So we would just say 2 times 2 is 4. And then off to the side, I would write negative 4 times A, which is 1, times C, which is negative 9. What does negative 4 times 1 times negative 9 equal? 36. So plus 36 over 2. Now what should I do? I add the 4 and the 36 together, and I get 40. Negative 2 plus or minus the square root of 40 over 2. Then I take 40 and I factor it. 10 and 4, 2 and 5, 2 and 2. Can I pull anything out? A 2. I bring out a 2, and I get negative 2 plus or minus 2 times the square root of the leftover stuff, which is 10 over 2. Now you have to be careful at this step. You can simplify if this and this and this all have the same factor. And notice I didn't circle the 10. The 10 is not part of the simplification process. Anything that stays inside the square root cannot be simplified any further. But do those three numbers have anything in common? 2, so I divide all of them by 2, and I'm left with negative 1 plus or minus, and it's 1 square root of 10, but I don't need to write it. I can just put square root of 10. Okay? This quadratic hits the x-axis in some numbers at some numbers that aren't very nice. All right? Okay. Well, what if the graph misses the x-axis? What if I had x squared plus 2x plus 10? If I were to graph that, that's probably overkill, but whatever. X squared plus 2x plus 10. You see that parabola up there? Looks like this. It misses the x-axis, but it still has roots. Every quadratic has 2 roots. Most of the time, those roots hit the x-axis, but sometimes they don't. And if the roots don't hit the x-axis, they are imaginary. They have eyes in them. So the only way to find it is to use the quadratic formula. There's another way, but I'm not going to teach it to you. So quadratic formula. Negative b would be negative 2 plus or minus the square root of 2 squared, which is 4. And then off to the side, I write this. Negative 4 times 1 times 10, which would be minus 40 over 2 times 1 is 2. Okay. Then I get negative 2 plus or minus the square root of negative 36 over 2. Can we take the square root of negative 36? We can now. Before we did 4.6 in the book, we didn't know how to do it. What is the square root of negative 36? 6i. This is equal to negative 2 plus or minus 6i over 2. Can I simplify anything? I can pull a 2 out of all of them. 2 divided by 2, negative 2 divided by 2 is negative 1. 6 divided by 2 is 3i. And then the 2 on the bottom disappears. And those are my answers. Negative 1 plus or minus 3i. Okay? Right, what if I had this? 5. Let's not do that. Let's do 9x squared plus 16. What are my a, b, and c in this case? 9 is a, b would equal 0, and c would equal 16. Good. So negative 0 plus or minus the square root of 0 minus 4 times 9 times 16. I'm going to need my calculator for this. Negative 4 times 9 times 16 is negative 576 over 2a would be 18. Well, this doesn't exist and this doesn't exist, so it simplifies down to plus or minus the square root of negative 576 over 18. Okay. Well, what goes into 576? If I add the digits together, 5 plus 7 is 12 plus 6 is 18. So 3 goes into it, but 2 also goes into it, so I know 6 will work. All right, 576, 6 and 96. This would be 2 and 3. This would be 8 and 12. 2, 2 and 2. 4 and 3. 2 and 2. So I'm going to get rid of everything that factored. Can I pull anything out? A set of 2s, a set of 2s, a set of 2s, oh, and a set of 3s. What do you notice? Everything came out, which means 576 is a perfect square. If I take the square root of 576, I get 24, which is the same thing I get when I multiply all those pairs together. 2 times 2 times 2 times 3 is 24. Okay, so what should I write now? Plus or minus 24, and that takes care of this, but there's still a negative, which we need to put an I over 18. Can I simplify 25 over 18? What goes into 25 and 18? 2 does. 3 does. 6 is the largest one. So I'm going to pull out a 6, and I get plus or minus 4i over 3. Okay? All right, what about this? Hold on a second. Let's change this to an 8. Oop, oop. Okay. What should I do here? I need to put everything on one side. I'm going to add the 4x, move it over, and I'm going to put it in the middle where it belongs. Negative 2x squared plus 4x minus 12 equals 0. Now I just use a quadratic formula. The opposite of b is negative 4 plus or minus the square root of b squared, which is 16. And again, I recommend that you write all of this off to the side. If you don't, there's a really good chance you're going to mess up the negative or the positive, depending on what it is. So off to the side, write negative 4 times a, which is negative 2, times c, which is negative 12. And I get 4 times 2 is 8. And 8 times negative 12 is negative 96. Everybody understand that? So I write negative 96 right here, divided by, what is 2a in this case? Negative 4. 16 minus 96 is going to be negative 80. Negative 4 plus or minus the square root of negative 80 over negative 4. Now I need to factor negative 80. 8 and 10. 8 is just made up of 3 2's. And then 2 and 5. What can I bring out? 2 sets of 2's and an I. Negative 4 plus or minus 2 sets of 2's would be 4 and the I. And then I have the square root of 5 left over. And I divide that by negative 4. Do those three numbers have anything in common? 4. So I'm going to pull out a 4. Negative 1 plus or minus 1 I root 5 over negative 1. But I don't like how that looks. Can I do something to fix that? Take out a negative. Okay? If I take a negative out of this, what do I get? 1. If I take a negative out of that, what do I get? 1. And do I need to divide by 1? Nope. So we won't do that. What happens when you take a negative out of that? Instead of plus or minus, it changes to minus and plus. Is that any different? No. So plus or minus I root 5. Does that make sense? Do you guys need to see another one? Okay, we're going to spend 2 days on this assignment. It'll be 4.7. Take a look at numbers 3, 4, and 5. I'm on page 249. So we're on page 249. Look at problems 3, 4, 5, and 6. In those first 4 problems, use the quadratic equation to solve the quadratic and then match it with the graph. Does that make sense? So on number 3, you'll use the quadratic formula and you'll get 2 answers, like x equals 3 and x equals 0, or something like that. And then look at the graph and match those roots with the correct graph. Okay? Don't graph them and then find the roots. You need practice with the quadratic formula, so use the quadratic formula. Okay, and then 7 through 20, you need to move everything to one side and use the quadratic formula. Okay? Some of the answers might be real numbers and some of them might be imaginary numbers. It just depends on the problem. But use the quadratic formula for all of them. And then 23 through 28, you're going to do the same thing. Okay? So your assignment is 4.7, 3 through 3 through 28 all, but skip 22. We don't need to do that one. Okay, that'll be good. 3 through 28 all, but don't do number 22.